Hello guys, hope you enjoyed your Easter holiday. This week we just have one homework lesson, then we'll have the work day, the test, and then we'll have a video that I will make a Zoom meeting link and you can go and watch it. It will be recorded so you can watch the video whenever you want, and next week we'll have a lab dealing with that video. Alright, so on page 539 we're talking about the probability of something or something else happening, not something and something else happening. So it's a little bit different. So if you look at the bottom of page 539, and I encourage you to read bottom of page 538 to 539, but 92.1 says, a card is drawn from a full deck. What is the probability that the card is an ace or a black card? Alright, so first of all, how many aces do we have? We have 4 out of a total of 52 cards. Plus, how many black cards do we have? Well, half of the deck is black, so that would be 26 over 52. But now, the thing is that what we did was we counted the 2 black aces twice. So we have to subtract those because their probability cannot be counted twice to find the total probability. So then we end up with 30 minus 2 is 28 over 52, which reduces to, let's see, 4 goes in there 7 and 4 goes in there 13, so 7/13. So you take the probability of each element happening and add them together, and then you subtract the one that you counted twice. Alright, so the next one. An urn contains 4 white balls and 3 black balls. 2 of the white balls are rough and 1 of the black balls is rough. What is the probability of drawing a ball that is either rough or white? Alright, so there's 7 balls. 4 of them are white, so that would be 4/7 plus how many of them are rough? Well, there's 2 whites plus 1 black, so that's a total of 3 that are rough. But we counted the ones that were white and rough twice. So that was 2 white balls that were rough, so we have to subtract those out so we don't count them in twice. So 4 plus 3 is 7, minus 2 is a total of 5/7 to get a white ball or a rough ball. Alright, on page 540 we're actually going to develop the formulas for permutations and combinations, and I may have done this when we first started talking about them, but this one says, take the permutations and combinations of 7 things taken 3 at a time to do a concrete development of the formulas for the number of permutations and the number of combinations. Well, the number of permutations of 7 things taken 3 at a time would be 7 times 6 times 5. Remember, we stopped there because there's only 3 of them being considered. But the way we worked a lot of this was we would multiply by, what would we need to multiply this by to make it a factorial? It'd need to be 7, 6, 5, 4, 3, 2, 1. So this would need to be multiplied by 4 factorial. But we can't just multiply by 4 factorial. We have to also divide by 4 factorial. So then this becomes 7 factorial over 4 factorial. Now, as far as a formula is concerned, how do we relate the 4 to these two numbers here? Well, isn't 4 the same as 7 minus 3? So that would be 7 minus 3 factorial. So now using the letters N and R, N is 7, so that's the numerator, so that would be N factorial over, this is N and this is R, so this would be N minus R factorial. So there's the formula for the number of permutations. the number of combinations, the only difference is that we also divide by the 3 factorial to undo the repetition so that we're not counting a combination twice. So the number of combinations is simply take this formula, which we just developed, and divide also by